Hello class, this lesson is 7.3 notes day 3. So as you can see, this 7.3 section is a very long section with a lot of material, so we're covering 3 days on it. This is the last day. So what we're doing today is we're answering the question, are the given roots a solution to the given quadratic function? So we have these as being the roots. 1 plus 2i, or negative 1 plus 2i, and a negative 1 minus 2i. So this is where the roots are of the equation. Is this the equation that the roots are for? So here's how we do it. Whenever we have complex roots, meaning they have an I in them, they always come in complex conjugate pairs. So when we have our roots, another way of saying that is those are what x equals. Those are the zeros of the function. So x equals these two. So x equals a negative 1 plus 2i. So please start writing this down. And x equals a negative 1 minus 2i. So that's what x equals. Those are what the roots are. Now class, like I said, another way of saying the root of a function is the zero of a function. We want to get a 0 over here on the right side and a 0 over here on the right side because we have a 0 over here. So we want everything to the left, and we want a 0 off to the right. So if I want to get a 0 over on this right side here, I need to add 1 and subtract 2i. So x plus 1 minus 2i, that equals 0. We also have x plus 1 plus 2i equaling a 0 over here for this one. So hopefully that makes sense. All I did was I set x equal to our roots. X equals this. And then I solved them for 0. Now class, what we're going to do is we want to form an equation out of these two. So the way that we do that is we multiply them together. So x plus 1 minus 2i, we're going to multiply it by x plus 1 plus 2i. That equals 0. So now we're going to multiply a trinomial times a trinomial. Hopefully you remember how to do that from chapter 5. I'm going to give you a couple hints as we go along the way. The first hint I'm going to give you before we even get started is that, as you can see, I have imaginary numbers in my trinomials. When you multiply them together, because they are complex conjugates like this, we know that the i's are always going to cancel out. So after you multiply, as you can see class, there's no i's in here, right? So we always know that when we multiply two trinomials together with complex conjugates, the i's are always going to cancel out. So every single problem on our notes for today, once you multiply them, the i's disappear. So watch as we do this closely. X times each term in this trinomial. So x times x is x squared. X times 1 is x. And x times 2i is 2ix. As weird as that looks, 2i times x is 2ix. Now we're going to multiply this negative 1 times all three of these terms. Sorry, not a negative 1, positive 1. So a positive 1 times x is a positive x. A positive 1 times a positive 1 is 1. And a positive 1 times a positive 2i is a positive 2i. Almost done. Now we just need to multiply this negative 2i times all three of these terms. So negative 2i times x is a negative 2ix. A negative 2i times a positive 1 is a negative 2i. And last term, a negative 2i times a positive 2i is a negative 4i squared. Whew! All that equals 0. Now we have a bunch of mess up here. Let's clean up our garbage. 2ix's and a negative 2ix's make 0ix's. They disappear. That's the great thing with multiplying conjugates together, is that the i's disappear. So now, this I squared right here. What does I squared equal? Hopefully you remember it's the same thing as a negative 1. So now we have a negative 4 times a negative 1, which is a positive 4. Oh, we have more i's that can disappear. Here's 2i, and here's a negative 2i, so they disappear. So there goes all of our i's. Now we're just going to combine like terms. X squared. How many x's do we have? Here's 1x plus 1x, making 2x's. So that takes care of that. That takes care of that. What do we have left over? We have this positive 1 and this positive 4. 1 plus 4 makes a positive 5. Those are all of our terms. So we have x squared plus 2x plus 5 equals 0. So our quadratic equation that has roots of -1 plus and minus 2I is the answer, x squared plus 2x plus 5. So going back to our question, are the given roots, these roots, the solution to the given quadratic equation? We need to see x squared plus 2x plus 6. Is that what we see? X squared plus 2x plus 5. So it's slightly different. So now we say, no, those given roots are not the zeros of our function written up top. They have to be exactly the same for us to put a yes there. So our answer is no. Let's try the next one. The roots are 2 plus I and 2 minus I. So that's what x equals. X equals 2 plus I and x equals 2 minus I. We want to see if after we solve for 0 and multiply them together, let's see if we get x squared minus 4x plus 5. So x minus 2 minus an I, that equals 0. And x minus 2 plus an I, that equals 0. So now we're going to multiply these two trinomials together. X minus 2 minus I multiplied by x minus 2 plus an I equals 0. It can be very intimidating to multiply these together right away, but remember that tip. Whenever you multiply these trinomials together, we always get complex conjugate pairs, which means the i's are always going to cancel out. So we're going to multiply this x times everything in here. X squared minus 2x plus ix. X times I is ix. Our next term, we're going to multiply this negative 2 times everything in here. So we have a negative 2x plus 4 minus 2I. And our last term, we're going to multiply this I times everything in here. So negative I times x is a negative ix. A negative I times a negative 2 is a positive 2I. And a negative I times a positive I is a negative I squared. All of that equals 0. All right, let's see what stuff cancels. A positive ix and a negative ix, gone. A negative 2I and a positive 2I, gone. A negative I squared is the same thing as a negative. I squared is a negative 1. So a negative negative 1 is now a positive 1. So what do we end up with? This x squared minus 2x is a minus 4x, and 4 plus 1 is 5. That equals 0. X squared minus 4x plus 5. So are these roots, 2 plus and minus I, are they the roots to this equation? X squared minus 4x plus 5, x squared minus 4x plus 5. Yes! Good stuff, right? Our answer is yes. Those are the roots. Now, class, if you're critically thinking right now, maybe you thought of this, maybe you haven't, you could just say, well, wouldn't it be much easier to just do the quadratic formula on this and see what the roots are? The answer to your question is yes. You could find if these are the roots just by doing the quadratic formula with this one. However, if you do that on a test, I will not give you credit because I want you to go through this work. And the reason why I want you to go through this work is not because I'm a jerk, is because on any standardized test that you might take, ACT, MCA, you aren't going to be given this. You might just be given these two roots and saying what is the quadratic equation with these roots, in which case you have to do all of these steps. So, bottom line, you could do the quadratic formula maybe to check your work if you want to, but it's best just to go through all this work as you see it, I have right here. That's what I expect from you on the test. So you guys try number 3 on your own. Set these equal to 0, and then multiply them together and see if you get the equation x squared plus 6x plus 13. After you have done this on your own, check your work with me. X equals a negative 3 plus 2i, and x equals a negative 3 minus 2i. So x plus 3 minus 2i equals 0. X plus 3 plus 2i equals 0. X plus 3 minus 2i times x plus 3 plus 2i equals 0. Multiplying a trinomial times a trinomial, you always know that the i's are going to cancel out if you do it correctly. X squared plus 3x plus 2ix plus 3x plus 9 plus 6i minus 2ix minus 6i minus 4i squared equals 0. 2ix, negative 2ix, 6i minus 6i. A negative 4 times a negative 1 is a positive 4. So our answer, x squared plus 6x, 9 and 4 make 13, plus 13 equals 0. Is that what we're supposed to see? X squared plus 6x plus 13. X squared plus 6x plus 13. We have another yes. Those are the roots to that quadratic equation. The answer is yes. Number 4 is a slightly different animal. In this one, we don't have imaginary numbers. We have irrational numbers. The square root of 5 is irrational. Take heart, you do it the exact same way. X equals a negative 2 plus square root 5. And x equals a negative 2 minus square root 5. Are these the solutions to this? So we're going to do it the exact same way. We're going to get a 0 over on the right sides. So let's add 2. And let's subtract the square root of 5. That equals 0. Let's add 2 and add the square root of 5. That equals 0. Now we're going to have a trinomial times a trinomial again. X plus 2 minus square root 5 is going to be multiplied by x plus 2 plus square root 5. We're multiplying this times this. That equals 0. In the same way on the first 3, all of your i's canceled out when you multiplied correctly. The same is true of your radical signs. When you multiply in today's lesson, if ever you see radical signs, after you multiply the trinomial times the trinomial, the radical signs are always going to disappear. And here's how they do it. X times everything in here. X squared plus 2x plus x square root 5. The positive 2 times everything in here is a positive 2x, positive 4, positive 2 square root 5. A negative square root 5 times everything in here is a negative x square root 5. A negative 2 square root 5. And a negative square root 5 times a positive square root 5 is a negative square root 25, which is a negative 5. Square root 5 times square root 5 is 5, and a negative times a positive is a negative. All right, let's see what mess we can clean up here. X square root 5 and a negative x square root 5 make 0x's square root 5. So we don't even have to write it. It's 0. A positive 2 square root 5 and a negative 2 square root 5 makes 0 square root 5s. 2 minus 2 is 0 square root 5s. So we don't even have to write it. So there goes all of our radicals. As you can see, they disappear. So our answer, x squared. 2x and 2x make 4x. And what do we have for our constant terms? 4 minus 5 is a negative 1. That equals 0. Is that what we're supposed to see? X squared plus 4x minus 1. X squared plus 4x minus 3. So this one, a negative 2 plus and minus square root 5, are not the roots to the given quadratic equation. So we would say no would be the correct answer for problem number 4. Now that you guys have watched me do number 4, you guys try number 5 on your own. Pause the video, try number 5. X equals a negative 1 plus square root 6. You're now checking your work. X equals a negative 1 minus square root 6. X plus 1 minus square root 6 times x plus 1 plus square root 6 equaling 0. Multiplying these together, hopefully you got all of your radicals to disappear. X squared plus an x plus x square root 6 plus 1 times x is x, 1 times 1 is 1, 1 times square root 6 is square root 6, minus x square root 6 minus square root 6. A negative times a positive is a negative. Square root 6 times square root 6 is 6. X square root 6 and a negative x square root 6, gone. A positive square root 6 and a negative square root 6, gone. So your answer, x squared plus 2x, 1 minus 6 is a negative 5. That equals 0. X squared plus 2x minus 5, x squared plus 2x minus 5. Your answer to this is yes, those roots do work for that given quadratic function. Number 5 is the answer, yes. All right, number 6 and number 7, the most trickiest of the problems for today's lesson, but nothing that we can't handle. This 0, I don't know how it got over here. It should be right here. A negative 1 plus or minus I squared 15 divided by 4. These are what x equals. Does these two solutions work for that equation? We're going to do it the same way with one additional step. If x equals a negative 1 plus I squared 15 over 4, and x equals a negative 1 minus I square root 15 over 4, we want to get a 0 over here on the right side. We want to get a 0 over here on the right side. So the first thing we have to do is we have to get rid of our denominator. So this is one thing that we haven't done in the past 5, is we have to multiply both sides by 4. And that way we get rid of our denominator. So now we have 4x equals a negative 1 plus I square root 15. And now, class, we can get a 0 over here on the right side in the same way we did on the past several. So we're going to add 1. So it's going to be 4x plus 1 minus I square root 15. I added 1 to this side, and I subtracted I square root 15 to get it onto the left side. Now that equals a 0. If you got lost, watch again as we do this one. So we're going to multiply both sides by 4 to get rid of that denominator. So now we have 4x equals a negative 1 minus I square root 15. Now I want a 0 on the right side, so I want to add 1. So we get 4x plus 1. And I want to add I square root 15 to both sides. So 4x plus 1 plus I square root 15. That equals 0. Whew! We got two nasty trinomials. Let's multiply them by each other, and let's see if something very, very ugly can turn very, very beautiful. It's the story of an ugly duckling. 4x plus 1 minus I square root 15 multiplied by this one. 4x plus 1 plus I square root 15. Class, these are complex conjugates. So we know all the i's will cancel out, and we know all that the radicals will cancel out if we multiply correctly. So that's a great check as you're doing your homework, as you're doing your test, as you're doing your accelerated math. It's a great check. 4x times 4x is 16x squared. 4x times 1 is a positive 4x. 4x times I square root 15 is, as ugly as this might be, 4ix root 15. Oofta. Next term, this positive 1 times the whole trinomial. plus 4x plus 1 plus I square root 15. I'm running out of room. Hopefully you guys still have room left. Multiplying this by everything, a negative I squared 15 times 4x is a negative 4ix square root 15. A negative I squared 15 times 1 is a negative I square root 15. And a negative I times a positive I is a negative I squared. We're multiplying the last times the last now. So a negative I times a positive I is a negative I squared. And square root 15 times square root 15 is 15. That all equals 0. All right, let's see if this mess clears up at all. So we have 4ix square root 15 and a negative 4ix square root 15 makes 0ix square root 15. You're gone. You're gone. We have a positive I square root 15 and a negative I square root 15, which makes 0i's square root 15. Those are gone. A negative I squared. Well, I squared is the same thing as a negative 1, so it's a negative, negative 1, which makes a positive 1 times 15. So this just becomes 15. All right, combining like terms, 16x squared. We have 4x plus 4x making 8x. And then our last one is 1 plus 15 making a positive 16. That equals 0. Every other time at this moment we've seen if this trinomial, this equation is the same as this one. And as you can see, they are very, very different. So instinctively we say no. But I want you guys to see something. What were to happen if I were to factor out an 8 right now? I would get 8, so now I would get 2x squared. 8 divided by 8 is a 1x, so just x, and 16 divided by 8 is a positive 2. That equals 0. Now, if I were to divide both sides by 8, that's gone. What's 0 divided by 8? Well, it's still just 0. So now I have 2x squared plus an x plus 2 equals 0. Is that what we're supposed to see? 2x squared plus x plus 2? 2x squared plus x plus 2. So your answer to this one is yes. Those given roots are the right roots for the quadratic equation 2x squared plus x plus 2 equals 0. So you had to factor out an 8 on this one, so make sure you're aware of that on your worksheets. Okay, last one. We got 5 roots on this one. We have 0, we have a positive 4, negative 4, positive 4i, negative 4i. Even though we have 5 roots, we really don't do much different. We set them first equal to x. X equals 0. X equals 4. X equals a negative 4. X equals 4i. X equals a negative 4i. Now we're going to solve all of these for 0. So get a 0 on the right side. This one's already done. X minus x equals 0. X minus 4 equals 0 for the second one. X plus 4 equals 0 for the third one. X. My smartboard's going crazy on me. X minus 4i equals 0. And x plus 4i equals 0. Now, we're going to set this times this times this times this times this, multiply all of them, and equal it to 0. So x times x minus 4 times x plus 4 times x minus 4i times x plus 4i. All of that equals 0. Now, we're going to multiply all 5 of those by each other, and once we do that, we're going to see if we get the function x to the 5th minus 256t equals 0. Whew! So you might be overwhelmed right now thinking, what in the world? I have to multiply all 5 of those by each other? It becomes very, very simple, actually. I want to show you a trick. Instinctively, we think, let's start at the left and multiply all the way to the right. which is good thinking. However, in this one, it wouldn't be the most productive thing, certainly wouldn't be the most efficient thing. Because we always know that conjugates, the middle term cancels out. So these two are conjugates, x minus 4i, x plus 4i. These two are conjugates, x minus 4 and x plus 4. The conjugates, when you multiply them, the middle term always cancels out. So let's multiply these two. Let's multiply these two, and then we can go from there. So multiplying these first two, the last two. X times x, we're foiling now. First, outside, inside, last. X times x is x squared. Here's minus 4ix plus 4ix is 0. I'm not even going to write it down because it's irrelevant. They cancel out. And then the last times the last. A negative 4 times a positive 4 is a negative 16i squared. And what does I squared equal? It equals a negative 1. And so what's a negative 1 times a negative 16? A positive 16. So I'm just going to write that down right now. X squared plus 16. Once again, a negative 4i times a positive 4i is a negative 16i squared, which is the same thing as a positive 16. So that's what happens when you multiply the fourth and the fifth by each other. Here's the second and the third terms. Let's multiply those. They're also conjugates. So x times x is x squared. Here's a positive 4x, negative 4x. I'm not even going to write it down because it's 0 x's. And then a negative 4 times a positive 4 is a negative 16. All that times x. Now once again, class, now you have to multiply three things by each other. Instead of multiplying left to right, let's multiply these two by each other. Why? Because they are conjugates. Conjugates, the middle term always cancels out, so it makes it so easy. So the first times the first is x to the fourth. We're going to multiply the outside, which is 16x squared, the inside, which is a negative 16x squared, which makes 0x squared. So don't even write it down. And then the last term, a negative 16 times a positive 16, is a negative 256. All of that is multiplied by x. Now multiply left to right, just distribute that x. So our answer, x times x to the fourth is x to the fifth. X times a negative 256 is a negative 256x. That equals 0. Is that what we're supposed to see? X to the fifth minus 256x. This should be an x right here. X to the fifth minus 256x. Yes, is our answer. That one is a doozy. Always remember, class, the i's or the radicals are always going to cancel out, and always remember to multiply the conjugates by each other first, because the conjugates, the middle term, always cancels out. So that's my advice to you on this worksheet for today. Set each of them equal to 0, multiply them by each other, always take heart that the i's will cancel out and the radicals will cancel out. Be sure to let me know if you have any questions or any trouble when you're doing this worksheet.